This is TANKD Steel Industries, one of Malaysia's biggest group of companies. TANKD Steel Industries are located strategically at Bangsa and Kuala Lumpur, Malaysia. It all started with collaboration between 5 students of University Technical Malaysia Melaka who had dreamed of their own company after completing a PhD in electronic engineering at overseas. Thus was formed TANKD Industries, which means the name of the students Tanesh, Azmina, Nazan, Khairatul and Dirshan. All of them now are Malaysia's top 10 engineers that handling skyscraper projects. TANKD Steel Industries had a remarkable period of continuing expansion accomplished by a rapid development in Malaysia with collaboration with biggest companies such as Tenaga Nasional Berhad, Top Glove Corporation, Petronas Global, Vibranium Wakanda and many more. Welcome to TANKD Steel Industries, one of the biggest group of companies. I am Dirshan, TANKD's company manager, and now I would like to introduce my colleagues. First of all is Ms. Wan Noor Azima, is our executive director. Mr. Tanesh is our research engineer. Ms. Khairatul Afika is our material engineer, and finally Mr. Nazan is our technical officer. Today I'm going to talk a little bit about 316L stainless steel. 316L stainless steel is a type of metallic alloy of stainless that is austenitic and contains nickel and molybdenum, which makes it corrosion resistant. The properties of nickel and molybdenum in high concentration helps prevent crevice and pitting corrosion. 316L stainless steel is also very durable and resistant to chemical contaminants and acid solutions such as bromides, sulfuric acid and chlorides. Thus, the role this stainless steel in Petronas Twin Tower is to further improve its corrosion resistance, heat resisting properties and formability. Also, it provides shiny look and strength and fatigue strength to the tower. Thank you.
Assalamualaikum and hi, my name is Wan Noor Azmina and my position in TANKD Steel Industries as Executive Director. We have 3 objectives. The first one is to provide a better understanding on the properties of the selected 316L stainless steel grade raw material. We also want to propose a better and enhance of the mechanical properties of 316L stainless steel for structural application. And we also want to present the technical findings obtained from our company in order to convince the client about the proposal that we make. Next is the problem statement. We have 2 problem statements. The first one is to identify the difference between the original 316L stainless steel and Gurun 316L stainless steel. We also want to discuss the suitable standard test method for the original and Gurun 316L stainless steel based on the tensile test performance.
Hi, my name is Tanesh Murugan and my position in TANKD Industries as a research engineer. For the technical finding, we have 4 categories. We have tensile strength, yield strength, modulus of elasticity and ductility. Tensile strength is the amount of fluid or stress that can be handled by a material before it stretches and breaks. Yield strength is the maximum stress that can be developed in a material without causing plastic deformation. It is the stress at which material exhibits a specified permanent deformation, and it is a practical approximation of the elastic limit. Modulus of elasticity, a quantity that measures an object or substances resistant to being deformed elastically when a stress is applied to it. The modulus of elasticity an object is defined as the slope of its stress-strain curve in the elastic deformation region. Then, ductility, a measure of material ability to deform before failure. Ductility can be quantified by reading the value of the strain at the fracture point on the stress-strain curve or by doing a % reduction in area of calculation. From the data given, we can conclude some of the findings as shown. For the mechanical properties 316L as original sample, we have thickness 2 mm, width 12.5 mm, gauge length 25 mm, and the area is 25 mm square. From the graph, we can get the yield strength 262.84764 MPa, tensile strength is 565.238 MPa, elastic modulus is 238053 GPa, ductility equals to 22.13% after multiplied by 10, and the fracture strength is 415.4468. For the mechanical properties 316L SS cold ruled, we have thickness 1 mm, width 12.5 mm, gauge length 25 mm, and the area is 12.5 mm square. From the graph, we can get the yield strength 976.0255,377 megapascal. Tensile strength is 984.28 megapascal. Elastic modulus 201921 gigapascal. Ductility equals to 1.95% after multiplied by 100, and the fracture strength is 642.01832.
Hi and Assalamualaikum. My name is Nurul Khairatul Afika binti Muhammad Suhaimi and my position at Tank Industry as Material Engineer. So I will talk about the relationship between microstructure and mechanical performance. The microstructure of material such as polymers, metal and ceramics strongly influence physical properties such as strength and high low temperature. The mechanical performance are also used to help identify materials and common properties. For the example, the strength, ductility and electromagnetic properties of materials are strongly dependent on the microstructure such as grain size, grain boundary, morphology and orientation distribution of textile. The microstructure feature that can be related to the mechanical performance: first, grain boundary phase content, and second, grain boundary phase composition.
My name is Muhammad Nazan Shahzad bin Azman and I'm a technical officer in TANKD Steel Industry Company. For conclusion, the carbon steel produced by cold rolling and processed at temperature close to room temperature is known as cold rolled steel. Cold rolled steel has a higher strength and mechanability than hot rolled steel. In comparison to hot rolled steel sheets are widely utilized for design goods with precise tolerance. Concentricity, straightness, and coat surface are required. Grade 360L may be easily formed into a variety of shapes using a brick or rule. 360L stainless steel with Gurun process is a highly realistic choice based on the Petronas twin tower corrosion since it fits several criteria. For example, has a superior finish than other grades of steel and is also very corrosion resistant, which is a crucial characteristic because Malaysian water is often rainy and rust will occur if the material is chosen incorrectly. This due to the height of the tower, which measure is 451.9 meters, is very high when compared to other building in Malaysia. Therefore, we must choose the very best material.